This is Algebra 2, 9-3, trig values of special angles. It's actually pre-calculus, but we're reviewing Algebra 2. So I want to show a cool trick with sine and cosine. So if we're on the unit circle, again, I'm going to embarrass myself if I try to draw that circle again. Let's do it like this. So I think if I hold shift, it doesn't quite work. And I go bigger like that. Make sure it's... If I hold shift, it should turn in, yeah, perfect circle. Anyway, if I have this on the unit circle, that looks pretty darn close. If I have this on the unit circle, that means that this hypotenuse is a length of, this hypotenuse is the radius, so it's now a length of 1, exactly. So if I come over here, I can say that this has a length of 1. And then I can find whatever angles I have over here, or what lengths I have. So review from 9-2, what length is over here if this, let's just call this theta, what if it was 60 degrees? Then this length right here would be?
Square root of 3 over 2.
Nice. And this length right here would be?
1 over 2.
1 over 2. Perfect. The cool thing with sine, and I guess I'm still kind of jumping the gun. Sine using SOHCAHTOA, what over what?
Opposite over hypotenuse.
Yep, opposite over hypotenuse. So opposite of this angle 60 degrees is this square root of 3 over 2. Let's just call this opposite for now. I'm going to do this in red. Let's call this opposite. And let's call this adjacent. Let's call this the hypotenuse is 1. So I'm going to relabel the 1 in red. So if it's, and this is an O, not a 0, so it doesn't have like a slash there. It's just opposite. I know it's confusing maybe a little bit, but if it's opposite over hypotenuse, it's going to be opposite over 1. So this is just equal to opposite, because this hypotenuse is 1. Which is cool because we've eliminated math. We've eliminated fractions by making sure that the hypotenuse is 1. Sine of theta is just the opposite because the hypotenuse is 1.
How would you write it though, since square root of 3 over 2 is a fraction?
Well, now you have a fraction because it's square root of 3 over 2. But in terms of getting rid of the fraction from the hypotenuse, you have gotten rid of it because you might have had a fraction over a fraction, which would have been nightmarish. But the whole point here is you only have to deal with one side. You don't have to deal with two sides anymore. Is that okay so far? All right. Analyze cosine. Cosine is what over what?
Adjacent over hypotenuse.
Adjacent over hypotenuse. And hypotenuse is 1, which means this is just equal to? Adjacent. Pretty nifty. And if I am on that, that coordinate plane, so there's my origin is right here, and then I go in this direction, go up, so y and x. So assuming that it's on the coordinate plane, now answer this question. On the unit circle, sine of theta will always give you the, is it the x coordinate or the y coordinate?
The y coordinate.
It's the y coordinate. That means if I'm looking at this point right here, this point has the coordinate pair. What is it again, Rochelle?
1 over 2 and square root of 3 over 2.
And square root of 3 over 2.
So that means that for on the unit circle sine of theta, it would be square root of 3 over 2.
Exactly. So it's asking for this when I'm asking for sine, and when I'm looking for cosine, it's going to be the other one. It's going to be this 1/2. So let's go ahead and fill that in down here. On the unit circle, cosine will always give you the, what should I say here, Rochelle?
X coordinate.
The x coordinate.
Or on the x-axis. Would that be another way to explain it?
Yeah, and how far you've traveled on the x-axis. That's another way to say it. I've traveled 1/2 in the x-axis. You might have gone a negative 1/2. You might have gone negative square root of 3 over 2. If you're going in the negative direction, you do have to be aware of that now. Because it's not triangles, we are going back to the unit circle. Triangles were a way of setting us up for the unit circle. So this is the thing that you have to memorize. The stars are the things that you just have to have at the tips of your tongue. And I think I've been thinking about this more and more. Everything that I star from the notes now on, I kind of want to build that into a Kahoot just so that we get this review over and over again. But just food for thought for next time, or maybe if I'm 3 years from now listening to this video, I'll be like, oh yeah, I should do a Kahoot. So sine of theta, that just gives you the, is it the y or the x again? Y, and then the cosine is the x. That's the rule. That rule right there. That you have to memorize, and you are ready for this whole whole unit or whole lesson. That's 9-3. 9-3 boiled down is just that. Let's go ahead and apply it. But it assumes that you've mastered 9-2 as well. You know your special right triangles. You know these units from the last lesson. So let's try this. Part of the warm-up was figuring out where these points are on the unit circle. This one, I was nice. I gave you where it is. On the ones on the back, I don't tell you where they are, so you have to figure them out. All right, so cosine of 60. 60 degrees is, you always go from the positive x-axis. So between this point and this point, I have a 60-degree angle that brings me up to this point. If I go ahead and draw my line straight down to the x-axis, always go to the x-axis. So I'm going to go use technology to make sure I have a nice straight line. This x-axis all the way down here. Then I have a 90-degree angle. So it's a 30, 60, 90 by construction. I always use the word construction, but geometry, people in geometry is like, that's not a construction, that's just a sketch. So assuming that the sketch is a 90-degree angle, that means we have an assumption that we have a 30, 60, 90. 30, 60, 90 means we know the dimensions of this, which means we know the coordinate of this. This coordinate is what, Rochelle?
1/2 and square root of 3 over 2.
Square root of 3 over 2. It's almost as if we just did it. Oh, wait, we did. It's right there. Okay, so cosine of 60 is therefore 1/2. It's the x-coordinate. Sine of 60 is
Square root of 3 over 2.
square root of 3 over 2. That's it. You could even box it if you want. Oh, whoa. The lag causes my boxes to not work. 1/2 and square root of 3 over 2. All right, slightly harder. Cosine of 225 degrees. First of all, where does 225 degrees live? Quadrant 1, 2, 3, or 4?
3.
3. Somewhere down here. Where down there? Is it, I mean, you have one of 3 spots. Is it there, there, or there? Is it A, B, or C?
It would be
First, second, or third?
third. Or in between. Wouldn't it be in between?
I don't know. Is it?
Yeah, it'd be in between the second and third.
Why?
Because it's 225, and usually it's like a 30, 60, or 45. I forgot.
Yeah, so whenever you see anything with a 5 in it, when you're in degrees, it's always going to be the middle one.
Yeah.
So that's a good way to tell, because the middle one is always the 45-degree triangle. Remember, the other ones are 30 and 60, which don't end with a 5, they end with a 0. So if you end with a 5, it's going to be that middle one. It's going to be cut straight in half between the x-coordinate or the x-axis and the y-axis. So coming back here, 225, that lives right there. Go ahead and graph it.
On worksheets, is there ever going to be a time where it's going to be in between 2 points?
No, not for
Okay.
ever, basically. Actually, in pre-calculus, you do eventually hit that, but it's a long ways off. That's going to be next semester. Don't worry about it for a while. Yeah, for this unit, you're good. It's always going to be some multiple of 45, 30, or 60. Well, and 60 is a multiple of 30, so it's always going to be a multiple of 30 or 45. From here, we need to label the coordinates, just the order of operations here, or not really order of operations, just the order of the procedure. The coordinates of this are what, comma, what?
Negative square root of 2 over 2, and negative square root of 2 over 2.
I was hoping I would trick you with those negatives, but you got it. It is negative in the x direction, negative in the y direction, so both the x and the y are negative. Now that we've labeled the point from lesson 9-2, in this lesson 9-3, we're actually calculating cosine of that angle. By the way, 225 degrees, that's this angle right there, and that cuts off right there. So this angle right there is 225 degrees if you want to visualize what that looks like. So cosine of 225 degrees, therefore, Rochelle, is?
Negative square root of 2 over 2.
Yeah, I mean, both of them are the same, so you're not going to get it wrong. Square root of 2 over 2. Both of them negative. All right. So far, so good. Now we have radians. Oh, boy. Radians. So 2 pi over 3.
It's going to be on the fourth.
It's going to be in the fourth quadrant down here.
Yeah.
Be careful, because pi is right here, right? So 0, 0 goes to pi, and then back
Oh,
around
no,
again.
it's
So
on
that's going to be
2.
2 pi.
It's on 2.
So it's in quadrant 2, because 2/3 is 2/3 the way between 0 and pi. 2/3 between 0 and pi. And 2/3, that means if I had to slice this angle here into 3 parts, I would slice them boink and boink. So I have a nice piece there, a nice piece there, a nice piece there, into nice thirds, which means my angle is going to be right about there. So let's go ahead and undo all that. My angle is right there, such that it makes a 60-degree angle with this x-axis. So that's 60 degrees, or you could say that that right here is 120 degrees, which is what this actually converts to when you do this into degrees. If you don't like radians, always convert to degrees by multiplying by what?
Pi, no, 180 over pi.
180 degrees over pi. Yep, just multiply by 180 degrees over pi if you don't like radians, and this will convert to 120 degrees, and then you have to figure out where 120 degrees is without using a protractor. You just have to know this. All right, we just did a lot of things. Meet with John. Oh yeah, that's right. So I have my point here. What's the next step, Rochelle?
You write your coordinates.
Yep. What are the coordinates?
It's gonna be negative 3 over 2.
Careful. So maybe we should back up. Let's go ahead and make our triangle. Yeah. If I make my triangle.
Oh no, it's negative 1 over 2.
So that's negative 1/2 here.
And it's positive 3 over 2.
Square 3 over 2. Just labeling our 30, 60, 90. We know that that's a 60-degree angle right here because I said that before. Also, you can just kind of visualize too. So say again, the coordinates are?
Negative 1 over 2 and square root of 3 over 2.
Beautiful. So therefore, cosine of 2 pi over 3 is?
Negative 1 over 2.
And sine of 2 pi over 3 is?
Positive square root of 3 over 2.
There it is. And that's all the examples we have. By the end of tonight's homework, we should just be able to say sine of 2 pi over 3. You might need to think about it for 60 seconds, but you should start be able to do these in your head. That's what I'm hoping. I know that is very complex. You're like, okay, I have to convert to degrees. Where is that on the unit circle? Okay, what type of triangle is that? What are the dimensions of the triangle? Am I asking for the x or the y? There's a lot of questions all embedded in one problem, but they're all simple questions if you have enough time to actually visualize it. So by the end of the homework tonight, again, please try to be able to do these in your head, and if not, just keep working on them. I have Quizlet up if you need. It's not on Classroom, but if you ask me, I can give you a Quizlet for these. But they are on Khan Academy. They just ask you for the cosine and sine of both of the same angle. All right, any questions? All right, that's it.